Answers to assignment questions. Question 125 to 131. In this question, there's a hot piece of metal and it is dropped into a container of cold water. Note that the initial temperature of the container was the same as that of the cold water. So, the cold water absorbs energy. The cold container also absorbs energy. And then there's energy released by the hot piece of metal. So, assume there's no heat loss to the surroundings. We may set up this equation and then find the specific capacity of the metal. In this question, there is a piece of copper block being heated over a Bunsen flame for 10 minutes. In part A, the teacher says that the initial temperature of the copper block is the same as that of the Bunsen flame. What's the reason behind? After 10 minutes of heating, we know that the copper block and the Bunsen flame should have reached thermal equilibrium, and therefore their temperatures should be the same. Then the hot metal block is dropped in the beaker of water at 25 degrees Celsius, giving a final temperature of 30 degrees Celsius. You are asked to find the temperature of the Bunsen flame. Assume there is no heat loss to the surroundings and the heat absorbed by the cold water should be the same as the heat released by the hot metal, and so we have that equation. And then we may find the initial temperature of the hot metal before it is dropped into water. And this, we assume it to be the same as that of the Bunsen flame. However, in part C, it says that the Bunsen flame should have an even higher temperature. Why? Because there is already heat loss to the surroundings when we transfer the block from the flame to the water. And so, the measured final temperature, 30 degrees Celsius, is actually lower than what it should be if there is no heat loss to the surroundings. Next comes an easier question. In this question, there's 1 kilogram of cold water mixing with 3 kilograms of hot soup at 98 degrees Celsius in an aluminium container. In other words, the container was also hot at the beginning. The energy absorbed by the cold water should be the same as the total energy released by the hot soup and the hot container. And so we have that equation. And in this way, we may find the final temperature. This is a question about beef ball noodles. 2 beef balls at 4 degrees Celsius is mixed with water at 40 degrees Celsius. You are asked to find the temperature of the mixture before it is heated. Assume there is no heat loss to the surroundings, then the heat absorbed by the cold beef balls should be the same as the heat released by the hot water. And in this way, we have that equation and you may find their final temperature. In part B, it says that it takes 5 minutes to heat the mixture to 90 degrees Celsius. And you are asked to find the power of the stove. Now the heat required should be given by the power multiplied with the time of heating. And so the total energy required is provided by the heater. And in this way you may find the power of the heater. In part C then, we add noodles at 15 degrees Celsius to the water, and then it takes another 1 minute to heat the mixture up to 90 degrees Celsius again. Note that for this part of the question, you may just ignore the beef balls and the water, and by just looking at the noodles at 15 degrees Celsius, you may find the heat required, and it is given by the heater. And in this way, you may know the specific heat capacity of the noodles. From the given diagram, you may tell at once that this is a special question type. In this question, the flow rates in pipe X and Y are given, and you are asked to find the final water temperature flows out from Z. To handle this kind of question with flow rates, you have to consider what happens in 1 second. And in this way, you may see there is 5 kg of cold water mixing with 7 kg of hot water. And so it's not too difficult to find their final temperature. Next is a question to find the specific capacity of stream. In this question, there is cold stream at 4 degrees Celsius mixing with hot water at 25 degrees Celsius and giving a final temperature of 18 degrees Celsius. It's not too difficult to set up the equation and find the specific capacity of the stream. And now, what about the internal energy of water? How does it change? The water temperature decreases, and so its molecular kinetic energy also decreases. And in this way, the internal energy decreases. Then we move on to part C, that the mixture is heated on a stove, and you are asked to find the time required for the mixture to reach 100 degrees Celsius again. So the energy supplied by the heater should be just enough for the mixture to reach 100 degrees Celsius. And in this way, it takes 344 seconds. In this question, you must know how to read the temperature graph. For part A, room temperature. The mixture should return to room temperature eventually. So the final temperature is the room temperature, 25 degrees Celsius. While the temperature immediately after the metal and the water are mixed together is 24 degrees Celsius. Answer for part B. Now then for part C, to find the specific capacity of metal, we set up the equation by assuming conservation of energy and no heat loss to the surroundings. Lastly, Ivy believes that replacing the container with a foam cup would be better. Why? Because a foam cup absorbs less heat from the mixture than a glass beaker, and so the heat loss to surroundings is even less. And so that will improve the accuracy of the experiment. Chapter 3.5 Importance of high specific heat capacity of water. Water has a very high specific heat capacity, and that means when water absorbs energy, its temperature does not increase too much. In this way, water can be used as a coolant. It is used in many air conditioning and cooling systems because it can bring the heat away very easily, as it absorbs a lot of energy from the heat source. On the other hand, water is also important for temperature regulation. So what is temperature regulation? That means when the body has a large amount of water, then it will be very difficult to change its temperature. So the high specific heat capacity of water can limit the temperature change, which then results in mild climate and body temperature regulation. Let's talk about the climate effect. First of all, in Hong Kong, one day, the temperature changes from 25 degrees Celsius to 35 degrees Celsius. However, the sea temperature does not change so much, that it changes from 27 degrees Celsius to 32 degrees Celsius only. Why? Because of the high specific heat capacity of water, it's difficult to change the temperature of the sea. The temperature change of coastal area, just like Hong Kong, will be less than an inland area because of the presence of the sea. And that's why we have a cooler summer and a milder winter than an inland city like Nepal. The another effect is the body temperature regulation. As our body is mostly water, it would be difficult to change our body temperature too much. And a stable body temperature is also important for many biological processes in our body. And that is to say, if water does not have that high specific heat capacity, our body temperature will change too much with the surroundings, and then we may get sick or even die too easily.